Hi guys, I am Ankita. We will look into the problem arranging coins. You have n coins and you want to build a staircase with these coins. The staircase consists of k rows where ith row is exactly I coins. The last row of the staircase may be incomplete. Given the integer n, return the number of complete rows of the staircase you will build. So context what they have told here is they have given n number of coins and you have to build staircase with these many number of coins. And what is the condition to build the staircase is if it is the first staircase row of the staircase, then it should be having one coin. If it is the second row, then two coins. Third row, three coins. Similarly, nth row will have n number of coins. It must be having n number of coins. This is the condition what they have told. So let's say given an example, let's say 7. With 7 is the number of coins they have given. How many rows can be built in the staircase? Complete rows. So first row will need 1, second row will need 2 coins, so 2 and 3. Third row will need 3 coins, so 4, 5 and then 6. And fourth row need 4 coins, but we are left over with only 1 coin, that is the 7th coin. And 3 more coins are required. So how many complete rows we have formed here? 3. 3 is the answer which we need to return. So this is the question. How can we solve this? So one simple brute force approach we can tell to this is let's consider n as 7 only. Okay, so with given n as 7 and let's declare a variable I equal to 1. Now what we need to do? So given n as 7 I equal to 1, let's start. So 7 is the number of coins we have at present. We need to build the first row, right, in the staircase now. 7 minus 1, 6 it will be. So we are left over with 6 coins, but one row is completed. So with these 6 coins, how can we build the second row? Yes, minus 2. 2 coins are needed for second row. So we are left over with 4 coins and we have built 2 rows now. So next we have 4 coins left. With that third row we have to build, so we need 3 coins. So we are left over with 1 coin. So we are left over with 1 coin, but 3 rows are completed. In the end, 1 coin is left, but the fourth row needed how many number of coins? 4. So that will give you 1 minus 4 will be minus 3, which is less than 0. So once you get this, stop. So what we need to return? We need to return 3 as the answer, right? You have to return this 3 as an answer. How will you return this 3 as an answer? 3 is nothing but I minus 1. It is I minus 1. And what is the condition we need to give? When you find n, we keep on decrementing n minus I, n equal to n minus I we are doing every time here, n minus I, n minus I, n minus I. Once you find n which is less than I, you can stop the loop. So until you have n greater than or equal to I, you keep on doing n equal to n minus I, okay, and you keep on incrementing I. We are incrementing I every time here. So n equal to n minus I we are doing, and we keep on incrementing I. Once you find I that is greater than n, we stop the loop. Until here you could see I has been less than n. So we need, in the end we need to return I minus 1. We can't return I will be 4 here. We have to return I minus 1, that is 3. So let's implement this and check whether it works. So int I equal to 1 while n greater than or equal to I, keep doing n equal to n minus I and increment I, and end return I minus 1. Let's check this. Yes, it works. Okay. So is there any other way we can implement for this? So if you carefully observe, instead of doing this going one by one and decrementing this, let's say if n equal to 7 is given. So we know the summation formula. What is the summation formula for a given n number of integers n into n plus 1 by 2, right? So can we use this over here? Yes, of course. So if n is 3, then it is nothing but 1, 2, 3. So if we add this, it will give you 7. 7 is the answer. 3 into 3 plus 1, 4 by 2. That will give you 7 as an answer. Sorry, not 7, it is 6. Yes. So with this 6, we have got 3 rows. So when it is given n as 7, can we do it? No. So how do we do it? This n and this n is not different. This is not different. Okay. So how can we solve this? Let's say we will start with same I equal to 1. First, okay, first let's start with I equal to 1. So when you are given I equal to 1, right, you do I into I plus 1 by 2 every time. What will give you? 1 into 1 plus 1 is 2 by 2. That will give you 1 as an answer. When I equal to 2, what is the answer? 2 into 2 plus 1 is 3. So 3 to the 6 by 2 will be giving you 3 as an answer. When I equal to 3, what do we get? As we done here, 3 into 3 plus 1 by 2 is 6. 6 an answer, as an answer. When I equal to 4, 4 into 4 plus 1, 4 5 is 20 by 2 will be 10. So you could see when 10 is exceeding the 7 here, the given n. So at this point you can tell I equal to 3 is an answer. So this is similarly, we are doing follow from I equal to 1 to n here. But do we really need to go in this way? We have to iterate each and every number? No, right? So can we apply binary search here because it's a sorted integer, right? Integers are in the sorted format. So can we apply binary search on answers here? Yes, we can. We need to calculate the same summation, but instead of doing it on all the integers, we just need to use the binary search. How? Let's keep the number 0, 1, 2, 3, 4, 5, 6, 7. Okay. Given this, let's apply the binary search. So let this be low and this be high, and mid will be low plus high by 2. Here in indexing and the number is same, so mid will be nothing but 3 here. 7 plus 0 by 2 will be 3. So let's apply summation for this, m into m plus 1 by 2. How much it will give you? Right now we have m equal to 3, so that will be giving you 6. So is 6, is it equal to n? Is it equal to n? No, it is less than n. When 6 is less than n, there is a chance that the answer will be right to the mid. So what we do when you find the current value, let's say current value, when the current value is less than n, we move left to mid plus 1. So left will be mid plus 1 for this condition when the current value is less than n. Similarly, if the current value is greater than n, it will be opposite, right? That will be nothing but high equal to mid minus 1. So what if the current value is equal to n? Then just return the mid. That itself will be the answer. So if in case n is equal to 6, then this present current value is 6, which is equal to mid n. So we return 3 as an answer. 3 complete rows can be formed. If n is given 7, then we got to know that currently we are having 6, which is less than 7. So what do? Left will be nothing but mid plus 1. Again you find the mid here. So this is nothing but 4 plus 7, 11 by 2. Again it is pointing here mid. So now you do 5 into 5 plus 1 by 2, that will be giving you 5 6 30, 30 by 2, 15. 15 as an answer. We have got current as 15. So is this 15? Now if you see, it is greater than 7. So that means this condition is come. So in this case, we have got to know that the current value will be, number of rows value will be left to the mid. So what do? Height will be nothing but mid minus 1. So now mid will be pointing to the same position now, because left and high, left and right are low or high. So low and high are pointing to the same position. So mid will be pointing to the same position. How do we calculate mid? Mid is nothing but low plus high by 2. Okay. So this is mid. Basic binary search. So now at 4 into 4 plus 1 is nothing but 5. 4 into 5 by 2 is 10. So when current is equal to 10, again this is greater than 7. That means again there is a chance that the mid will be, the given answer should be left to mid. So what do? High will be nothing but mid minus 1. So here high will be pointed. Now you can see high and low have been crossed to each other. It has been exchanged. Now low is higher than the high. At this point we'll stop the loop. So what is the answer we need? 3. So where is 3 here? This is the 3 we have. Where is 3 here? It is which pointer is pointing to 3? That is nothing but high. So this is the answer which we need to write. So it is the same logic. Instead of iterating from I equal to 1 to n, we do the binary search on the answers. So just go to that, you find the mid, and from the mid you find the summation. Once you found the summation, just check whether it is equal to n. If it is n, of course you can return that mid. If it is lesser than, means you just move to the next right pointer. If it is greater than n, then move to the left pointer. That is the only simple condition we have to follow. Let's try it out now. Low equal to 0 and high equal to n. So why low lesser than or equal to high? What do we need to do? First we have to calculate mid. Is nothing but low plus high by 2. So next, okay, we have to calculate the current value. So that is nothing but mid into mid plus 1 by 2. If the current value equal to n, sorry, then just return the mid. Else, what if current value is less than n? Then in such case, we have to move to the right pointer, right? So low will be mid plus 1. Otherwise, the last condition where high will be mid minus 1. Then the current value is greater than n. So, and the answer is return nothing but high. High is the answer. If you get confused to keep track of this high, just every time, yeah, you can take a one more variable and store the value every time. Okay. So now we will run this. Yes, it is running. We'll submit this and check whether it passes all the test scenarios or not. Okay, this is causing an overflow. Then we will be need to use long everywhere. So when you use long, we have to return int as an answer. So just typecast it to int. Yeah, I think it will work now. Yes, it has been submitted. And the same you can use it in C++ as well. Okay, we will submit here also if needed. Yes. Thank you. I hope you understood the problem. If you have any queries, please drop it out in the comment section.